we're witnessing a fundamental shift in artificial intelligence. For years, we've interacted with AI through simple conversations: type a question, get an answer. But that era is ending. The next generation isn't about chatbots that wait for your commands. It's about AI agents, autonomous systems that can perceive their environment, reason through complex problems, and take meaningful action in the real world without constant human supervision. These aren't science fiction. They're here, they're powerful, and today, you're going to build one from the ground up. Let's dive in. Before we start coding, we need to understand what fundamentally separates an AI agent from a traditional chatbot. And it all comes down to three revolutionary capabilities. First, perception. Agents don't just process text, they actively sense and understand their environment, reading context clues and environmental signals. Second, reasoning. Instead of generating a single response, agents engage in multi-step logical planning. They break down complex goals into actionable subtasks. Third, action. This is the game changer. Agents can actually do things: search the web, execute code, modify databases, send emails. They change the world around them. Traditional chatbots are reactive, they respond. AI agents are proactive, they solve. That's the paradigm shift we're exploring today. Now let's pull back the curtain and examine the internal architecture that makes all of this possible. At the foundation, we have the LLM core. Think of this as the agent's brain. It's a large language model like GPT-4 or Claude that handles understanding, reasoning, and decision-making. Surrounding that core is the memory system, and this is crucial. It's divided into two distinct layers: working memory for immediate context, like your short-term recall, and long-term memory for persistent knowledge storage, similar to how you remember facts you learned years ago. Next is the tool layer. This is where the magic happens. These are the agent's hands and eyes: search engines to gather information, code interpreters to analyze data, file systems to store results. And orchestrating everything is the controller, a sophisticated loop that continuously cycles through reasoning and action, observe and adapt. This is what creates the illusion of intelligence. Each layer communicates with the others in real time, creating a unified, autonomous system. Alright, enough theory. Let's get our hands dirty. To build your first agent, you need the right foundation, and fortunately, the open source community has done the heavy lifting for us. We'll be using LangChain. It's currently the most mature framework for agent development, providing pre-built components for memory, tools, and reasoning loops. Think of it as the scaffolding for your agent. For the brain, we'll connect to either OpenAI's GPT-4 or Anthropic's Claude. Both are excellent reasoning engines with strong function calling capabilities. And for persistent memory, we'll use ChromaDB, a vector database that lets your agent remember and recall information across sessions. Let's install these dependencies now. Open your terminal and follow along. These three commands will set up everything you need to start building production-ready agents. Here's something fascinating: an agent's intelligence doesn't just come from the model, it comes from how you configure its consciousness. And that configuration is the system prompt. Think of the system prompt as the agent's constitution, the fundamental rules that govern its behavior. We need to define three critical elements. First, the role. Who is this agent? A research assistant? A coding companion? A data analyst? This sets the agent's identity and expertise domain. Second, the goal. What is the agent trying to achieve? Finding reliable information? Solving technical problems? Automating workflows? Crystal clear goals prevent the agent from going off track. Third, the constraints. This is your safety layer. What should the agent never do? Always cite sources. Acknowledge uncertainty. Refuse unethical requests. These constraints keep your agent aligned with your values. This prompt isn't just instructions, it's the agent's worldview. Get this right, and everything else follows. Get it wrong, and you'll have an unpredictable system. So take your time crafting this. It's the most important code you'll write. An agent with intelligence but no capabilities is just an expensive chatbot. So now we're going to give it superpowers through tool integration. In the agent world, tools are simply Python functions, but with a twist. Each tool comes with a detailed description that tells the agent when and how to use it. This is crucial because the agent needs to understand not just what a tool does, but in what situations it's appropriate. Let's look at 3 essential tools. The search tool connects your agent to the internet, real-time information at its fingertips. The calculator handles mathematical operations with precision that LLMs can't match on their own. And the file system tool lets your agent read and write data persistently. Here's what's incredible: you define these tools once, and the agent learns to orchestrate them dynamically. It decides which tool to use, in what order, and how to combine their outputs. You're not programming explicit workflows, you're providing capabilities and letting the agent figure out the optimal strategy. This is where your agent transforms from intelligent to useful. Tools are the bridge between reasoning and real-world impact. Now we get to the heart of agent intelligence, the REACT loop. REACT stands for reasoning and acting, and it's the cognitive cycle that makes agents appear to think. Here's how it works in practice. The agent enters a thought phase, it analyzes the current situation and formulates a plan. I need to search for the latest research papers on this topic. That's pure reasoning. Next comes action. The agent selects a tool and executes it with specific parameters. Call web_search with query, AI Agents 2025 Research. Now it's engaging with the real world. Then observation. The agent receives results from the tool. Found 10 academic papers and 5 industry reports. It's gathering new information. Finally, reflection. The agent evaluates whether it's achieved the goal or needs another cycle. I have enough sources, but I need to analyze the key findings. And the loop continues. What makes this powerful is the iteration. The agent doesn't just execute a fixed plan, it adapts in real time based on what it discovers. If a search returns no results, it reformulates the query. If data is incomplete, it seeks additional sources. This adaptive loop is what separates rigid automation from genuine autonomy. Watch any advanced agent work, and you'll see this cycle happening dozens of times per task, thinking, acting, observing, reflecting, until the goal is achieved. Imagine having a brilliant assistant who forgets everything you told them 5 minutes ago. Frustrating, right? That's an agent without memory, powerful but limited to single interactions. Professional agents need 2 distinct memory systems, and understanding this distinction is critical. Short-term memory is your conversation buffer, the recent context that keeps the agent grounded in the current task. The user asked about Python 3 messages ago. We just searched for documentation. This memory is temporary and lives in the model's context window. It's vast but limited in scope. Long-term memory is where things get sophisticated. This is persistent storage using vector embeddings, a technique that converts information into mathematical representations. When you tell your agent, "I prefer technical explanations with code examples," that preference gets embedded as a vector and stored in a database like ChromaDB or Pinecone. Later, when you ask a new question, the agent performs a similarity search. What do I know about this user's preferences? The vector database returns relevant memories, and suddenly your agent provides consistently personalized responses across sessions, days, or even months. This is how you build agents that truly learn and improve over time. Memory transforms a stateless language model into a persistent, personalized assistant that grows more useful with every interaction. Theory is great, but let's see this in action. I'm going to give our agent a real task and let you watch its complete thought process unfold in real time. The task: research the latest developments in AI agents for 2025 and write me a concise 200-word summary with key trends. Watch what happens. The agent doesn't just blindly start searching. First, it enters a planning phase. I need current information, so I'll use web search. I should look for academic sources, industry reports, and tech news from multiple angles. Now it executes 3 separate searches with refined queries. AI Agent Research 2025, Autonomous Agent Frameworks, Enterprise AI Agent Adoption. It's being strategic. Results come flooding back, 10 articles, 5 research papers, 3 industry analyses. The agent doesn't panic with information overload. It synthesizes common themes emerging, multi-agent systems, improved reasoning, tool integration, enterprise adoption growing. Finally, it generates output, a structured 200-word summary highlighting those exact trends, with citations to the sources it found most credible. The entire process took maybe 30 seconds. No human intervention. Just pure autonomous problem solving. The agent perceived a goal, planned a strategy, executed across multiple tools, synthesized disparate information, and delivered a polished result. This is what separates an agent from a chatbot. This is the future of AI interaction. What we've built today is powerful, but it's just the beginning. The next frontier isn't single agents working in isolation. It's multi-agent systems, networks of specialized agents collaborating to solve complex, multidimensional problems. Picture this workflow. A researcher agent specializes in information gathering. It knows how to query databases, scrape websites, and evaluate source credibility. It finds raw material. That data flows to an analyst agent, a specialist in statistical reasoning, pattern recognition, and data interpretation. It identifies trends and insights. The insights move to a writer agent, optimized for clear communication, storytelling, and audience adaptation. It transforms analysis into compelling content. Finally, a critic agent reviews everything with a quality-focused lens, checking for accuracy, coherence, and completeness. If it finds issues, it sends feedback back through the chain. This isn't science fiction. Companies are deploying these architectures right now. AutoGPT, MetaGPT, CrewAI, these frameworks enable agent teams to tackle enterprise-scale challenges that single agents simply cannot handle. We're moving from an AI that helps you to an AI workforce that operates semi-independently. The orchestration challenges are significant, but the potential is revolutionary. Multi-agent systems represent the evolution from AI assistants to AI organizations. You now understand the core principles of agent development, but knowledge without action is just entertainment. So let's talk about your next practical steps. Start small and iterate. Don't try to build an enterprise-grade system on day one. Create a simple calendar agent that can read your schedule and send reminders. Master that, then expand. Focus on prompt engineering. I cannot stress this enough, 80% of agent performance comes from how well you craft that initial system prompt and tool descriptions. Spend time here. Test different phrasings. A/B test your prompts. Monitor your costs carefully. Agent systems can rack up API bills fast because they make multiple LLM calls per task. Set usage limits, implement caching, and track your token consumption. I've seen people accidentally spend hundreds of dollars in a weekend because they didn't set guardrails. Study open source implementations. The GitHub repositories for LangChain, AutoGPT, and BabyAGI are gold mines of practical patterns. Don't reinvent the wheel, learn from production systems. And here's the most important advice: build in public. Share your agent projects on Twitter, write blog posts, contribute to open source frameworks. The agent developer community is incredibly collaborative right now. We're all figuring this out together. The tools exist. The knowledge is accessible. The only thing standing between you and a working agent is action. So close this video and start building. And that's it, you've just completed a crash course in AI agent development. From core concepts to production architecture, you now have the mental models needed to build autonomous AI systems. But here's the thing, this field is evolving at breakneck speed. What I showed you today will be outdated in 6 months, not because it's wrong, but because the technology keeps advancing. New frameworks emerge, new patterns are discovered, new capabilities unlock. So if you want to stay on the cutting edge, hit that subscribe button. Next week, we're diving deep into multi-agent orchestration, how to build agent teams that collaborate, delegate, and solve complex problems together. And I want to hear from you. What will your first agent do? Calendar management? Research automation? Content creation? Drop your ideas in the comments, the best one might become our next tutorial. Remember, the age of autonomous AI isn't coming. It's here. The question is, will you build it, or will you just watch others build it? I'm betting you'll build. See you in the next one.